Okay, so far with integrating with substitution, we have not yet seen these numbers, right? We haven't done that yet. Every problem we've done has just been plus C at the end, no numbers to plug in, not worrying at all about that. Well, these numbers are x values, right? They're if you think about the graph of some kind of curve, it's it's A and it's B. It's these x values right here. And so x values go with x values, dx, it all lines up very well. But when you do use substitution, we know that you have to have a proper u, you have to have a proper du, okay? And this should say 2x dx. That's a typo because the derivative of x squared and all that stuff. And so that works out very nicely. And we know that we can't sub some of the stuff in for u and leave some of the x's alone. We know that it has to be all u's or all x's. And so that is including these numbers right here. Okay? So let's go ahead and write down what the integral would be. And then we're going to see what these numbers are going to be. So we know we have u cubed. And then the x dx is going to be 1/2 du. This is something we've done a lot. Now I'm going to go ahead and put the 1/2 in front and hope that everybody's okay with that. And we know that was going to be our next step anyway. Yeah. So I cannot put 1 and 0 here because those were x values. And so they have this kind of listed down here. So to change the bounds, we're just going to use our u substitution. So if u is x squared plus 1, the upper bound, x equals 1, well, we just plug it in. 1 squared plus 1 is going to be 2. That's going to be our upper bound. Okay? Our lower bound, which was x equals 0, we plug it in. 0 squared plus 1, lower bound is 1. And so that's really all that's new for today, is knowing to change these bounds. There's not a lot of new stuff. I mean, kind of, that's the new part, and then we're going to be reviewing a little bit already. Couple of things. What happens if you plug in a number and from some weird circumstance, these two numbers end up being the same?
It's just 0.
The whole integral is 0. Think of it this way. If A and B were right on top of each other, that area would be nothing, right? There would be no area. What if somehow the bigger number produced a smaller number, meaning like you plug it in, but the 1 and 2 are switched? You flip them, and then that makes that you need to put a negative sign in front of your integral, and you're going to get to practice a little bit of that in homework, okay? So we haven't talked about that too much in a while. So to go ahead and finish this problem, we'd have 1/2. What is the antiderivative of u cubed? 1/4 u to the 4th. And then we're going to plug now 2 and 1 in. We cannot plug in the old x values. We have to plug in the u values. So we have a 1/8. And then 2 to the 4th. Remember, and then minus 1 to the 4th. It's been a while since we've done this, so just as a quick review. And any numbers like this, as long as it applies to the whole thing, you can pull it out to the front. And so, do y'all remember what I said about squared? I just gave it away. What I said about taking stuff to the 4th power? What makes that easier? Square it again. So 2 squared is 4, 4 squared is 16. 1 to any power is 1, and so we end up getting 15/8. That's the answer. And so a couple of things to say before I move on is that we actually could have done the u substitution, gone back to x values, and used my original bounds. Can anybody think about why that might not be the thing you want to do?
Because there's new bounds.
So there's new bounds, but I'm just saying you could have kept the old bounds if, instead of sticking with u, I had replaced the u back with x squared plus 1. Anybody think of why that might be something you don't want to do? Let me ask you, is it easier to simply take a number to the 4th root, or the 4th power, or do you want to square that number, add 1, then take it to the 4th power? Which is easier?
First one.
The first one, right? That's why you want to stick with u. Now, and you're going to see pretty soon, there's going to be some problems where you don't have any choice because the answer they want is actually just looking at it in U form. So you're going to be forced into doing U substitution. This whole idea of U substitution is not a strategy I'm teaching you because I think it's interesting. It's a required skill for the AP Calculus test. And so all students for a really long time have used U substitution in this way. All right, so let's look at the next problem. And I go ahead and tell you that this is a TOCO problem. When do we have TOCOs?
When we have an X that's not findable.
Yeah, X or really anything that other than a number. If and so for everybody else, just make sure you understand. If here we have a U, what should U be?
2x.
2x minus 1, good. And du?
2dx.
2dx. Now, we know we're going to divide that 2 over. Okay, that's nice. And I have the dx, so I can replace that dx with 1/2 du, but since there was no x here, and there is an x here, it's like accounted for. Just as a review, this is what we learned on Thursday. So that's how you know. Go ahead, sorry. Did somebody ask me a question? Talking it out? Okay. So if this x had not been here, it wouldn't have been a TOCO problem. And also, if instead of 2x, this had been like already an x squared, that would have produced an x down here, and then that x would have been kind of like grouped with the dx. So I'm just saying this to kind of get you in the mindset, because on the test, you're not necessarily going to be told that it's a TOCO problem. All right, and so you're going to have to figure that out. All right, so that means we've got to solve for x. So we solve for x up here, we'd add the 1, and we divide by 2, right? Okay, now let's change the bounds. All right, so first of all, the upper bound was 5, and this is an x value. We need to change it to a u value by plugging in 5 right here. So twice 5 minus 1, 9. And then the 1 is going to change into, what's 2 times 1 minus 1? So 1. So this number didn't actually change. There's a whole variety of things that could actually happen here. Just follow the numbers and take what you got. All right, I'm going to circle this because this is the new part of what we're doing today, and so that's important. When you rewrite your problem, I'm going to suggest you go ahead and write those new numbers immediately. As soon as you find them, go ahead and write them so that you don't forget that those numbers changed. Okay, so in place of x, I'm going to write u plus 1 over 2. What am I going to write in the denominator here?
U to the half.
So I could write u to the half. I'm going to do that in the next step. If you wrote that, though, that would be fine. I'm going to go ahead and just write it as square root of u. And in place of dx, I'm going to write 1/2 du. Now, if all the directions were to rewrite this integral in terms of u, I did that. And this is an acceptable answer. However, let's say the directions are the same, but instead of it just being open-ended, it was multiple choice. Do you think a multiple choice answer would be this messy? Probably not. So let's practice simplifying it, and then we're actually going to kind of see this one through to the end, because it could be that that's what you're asked for, although that's kind of a long problem. So we know we're going to move the 1/2 to the front. We have our integral, 1 and 9. Like Brett said, this is really u to the half. Since it's in the denominator, we're going to pull it up, and it's going to be u to the negative 1/2, and I'm going to need to distribute that to the u plus 1. And so remember, this is what we learned on Thursday. This is just finishing up the TOCO problem. A lot of algebra. So then I have 1/2. Still not ready to integrate, so I'm going to go and write 1 and 9 again. And what's my next step? Oh, yeah, you're right. I'm just kind of like in my mode, finishing out the day. So u plus 1 really is over 2. So, Catherine, is that what you were going to ask too? Okay, so let me use this blue color. So the 1/2 moved to the front. This is also a 1/2. So what number really should be in the front?
1/4.
1/4. Thank you for keeping me on my toes. Actually, I'm gonna erase that. 1/4. 1/2 times 1/2, that's 1/4 for both of these halves. Okay. So then now we're ready to distribute. No other mistakes? Possible. Okay, so what's the power on U?
Positive.
Positive 1/2, because you're going to add the powers. Negative 1/2 plus 1, that's a positive 1/2. And then the next one's easy because you're just multiplying by 1, so we basically just rewrite it. Now, if this were a multiple choice problem and the directions were just to rewrite this integral in terms of U, then this would be probably what the answer choices look like. Okay, so just know that you're not going to have to do everything on every problem. Now, I do want to practice going a little bit further than this, and so let's go ahead and now integrate this, and it's possible that's what the answer choices are. So what's the antiderivative of U to the 1/2?
2/3 to 3/2.
Yeah, 2/3 U to the 3/2. Now, if you're still struggling with this, remember, you can break this down into 2 steps. Leave a space, write the U, add 1 to the power, and write the reciprocal in front of it. Okay, and then we'll deal with the 1/4 later. Okay, over here, what's this antiderivative?
2U to the 1/2.
2U to the 1/2. And now the numbers I'm going to plug in are going to be 9 and 1. Okay, so notice that the integration symbol and the du are gone because I did the antiderivative. I still have the numbers because I'm going to plug them in, and sometimes we see it just as a bar. I went ahead and put brackets because the 1/4 should be multiplied to everything, so I wanted to make sure that was known. All right, so let's move it on up here and let's think about, okay, what do we have now? All right, so I have a 2/3, and the first number I'm going to plug in is a 9. So 9 to the 3/2. I feel like I'm going to run out of room. Plus 2 times 9 to the 1/2 minus, now I'm going to be a little bit, I'm going to take the easy street here. I know if I plug 1 in, I'm just going to get 1, right? So I'm just going to subtract 2/3 and 2, kind of like that. And I did have to put them in parentheses after the minus because I'm subtracting everything. Okay, have I gotten rid of all my variables? Yeah. So if this was an open-ended question, you know, on the AP test, you really don't have to simplify this. You could stop here. But again, if we had multiple choice, all the answer choices would be numbers, and you'd have to kind of crunch out those numbers. I'll just tell you that I would not put all of this in one problem. This is a lot. It's a big problem. Okay?
I'm sorry, where did the 2/3 plus 2 come from?
Because I'm plugging in 1 and I just didn't write it. Like up here, I wrote it as 2/3, 9 to the 3/2. I just know that 1's not going to change anything.
Right, sorry.
And so I'm even going to cheat here. I just don't want to spend a lot of time on this answer. You get 16/3. Now, if you're like, I don't want to, but I know how to calculate that, you're in good shape. If you honestly are not sure how to do this number crunching, we need to get together and kind of go over how to do some of these things. I know you probably know it, but you just might not remember exactly. Okay, but like I said, this is a lot in one problem. So just know that I'm going to be reasonable, and even the AP test is pretty reasonable. Okay, so on this next problem, look at what we're given. What's different about this one?
A and B.
Yeah, A and B instead of numbers, and that can happen. And this kind of gets weird because I already had an X, and I was going to have a U. Now I have an A and a B. So it's like letters upon letters upon letters. But let's just take the problem. I see some answer choices, and there might be some that you think you know are the answer. If you're looking at this and you're like, I know what the answer is, just lightly circle it, and let's see if you're right. I don't want to take a poll, but I don't want to give it away. All right, what would be u if we were doing this problem? X squared plus 1. Okay, then du would be 2x dx, right? And I'm going to immediately move that 2 over. I know I don't have to work out this whole problem, but if you just go with what your strength is, you're going to get there, okay? Doesn't look like a TOCO problem because I have an x dx and then there's an x and a dx here. So now I've got to change my letters, okay? So b, what is b going to become? B squared plus 1, and a is going to become a squared plus 1. So which two answer choices are like not even close? A and B. They forgot to change their bounds. You know, a lot of students might want to pick A because it looks good to them. They see the half, they like the half, and they just go for it. Okay, but which is the answer? C. If you're not being careful, you might think the answer is D, right? If you're not thinking, oh, I have to divide that 2 over, you might think the answer is D. So just don't try to take too many shortcuts here. This is not a long problem, and so, you know, trying to take shortcuts and make it into like a really, really fast problem could get you the wrong answer. All right, go ahead and turn the page now. And this is homework, and you're going to have some time, even with that fire drill, you're going to have some time to get a lot of this stuff done. But I want to give you a few pointers before you just go with it, okay? And this is not optional. Everybody's gonna work on this here when I finish what I'm saying. And I designed it this way because you have homework tonight and you have homework tomorrow, even though I don't see you. So it'd be best if you can get some of it done in class. So anyway, so notice that 1 and 2, multiple choice problems. You don't have to do the whole problem. A little bit of trig on 1. Just know that all the little mistakes, there's an answer choice there. Okay, beware of cannot be determined. In the SAT, that's like never the answer. Yep. Okay, not in my lifetime anyway. So AP test, I'm not going to say it's never the answer, but you need to be aware of it. Don't pick it because you just don't know how to do it. Anyway, that'll be fun. All right, let's look at, this is really what I want to point out, because some of you are bad about reading directions, and if that's you, you're going to end up doing a lot more work than everybody else. So it says, given the following integrals, define u. So you're going to have to do, these are all u substitutions, figure out what u should be, and then indicate the new integral would be in terms of u with the change of bounds. Okay, so like your answer here is, okay, there could be possibly a number, there's going to be new numbers here, right? They're going to change. And then there's going to be u, blah, 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 du. This is your answer. You do not have to go any further than this. You can if you just really want to, but you don't have to. I want you just to get into the changing of the bounds and that whole setup part, okay? There might be some TOCOs in here. We'll see. Although those shouldn't be too bad because you don't have to finish them. All right, if you look on the next page, a few more, same thing. You don't have to finish them, just basically setting them up. And then 9 and 10 are some multiple choice, okay? Do me a favor and put parentheses on 9. There really should be parentheses right here, and that's just something I hadn't got around to fixing. Probably that really wouldn't throw you off, but they should be there. Okay? So that's what we're doing for the rest of class.